stopper with the metal can. But the metal piece goes through and then becomes a flat, kind of thick, this is the fixed leaf, that's that stainless steel one. And then the metal piece comes down and then soldered on it is a piece of foil. Now, when the negative strip was brought near, you saw that leaf move out. And that's what they're asking here in 17. Describe the movement of electrons when the negatively strip is brought near. And one of the things they want to emphasize is air is not a conductor. So in other words, there is air right here. Meaning, did any of the electrons on the vinyl strip flow through the air onto the knob? No. It's an insulator. Insulator means the electrons can't flow. So the electrons did not move from the strip. However, remember, negatives are repelled each other through that electric field. So even though they don't actually touch, and remember, this electroscope was neutral, I would say that I had a bunch of positives and a bunch of negatives up here in the knob, an equal number of them, before I brought the strip near it. When I brought it near, what happened is these negatives went rushing down. They were pushed away. Remember, they can flow. That was the key. The electroscope is a conductor. The air is not a conductor. So the electrons did not flow from the vinyl onto the knob. But what did happen is the electrons that were in the knob were then flowing down to not only the fixed leaf, but also the movable leaf. In other words, remember that pit ball that was neutral, and we talked about when it got close to it, they separated and become polarized. That's what happened here. This electroscope became polarized. The whole electroscope is still neutral. In fact, I think I'm getting to the next question in 18. But what happened is there was a response. And that response was that the movable leaf moved away from the fixed leaf because both of these leaves are negative. And the reason both of these leaves are negative is because they came down from the knob that is positive. And so I think I probably went farther than I needed to just for 17, but let me just backtrack to answer 17. It says here, describe the movement of the electrons when the negative strip is brought near it. I would say the movement of the electrons is that they moved from the knob down to the leaves. They really want you to get to the idea that it did not move from the strip to the vinyl strip to the electroscope. Okay? But they moved within the electroscope because the electroscope is a conductor. Now, I think I've also answered 18 here. It says, when the negatively charged strip near the electroscope, what is the charge of the fixed leaf? And of course, negative. The negatives went down. They went on to the fixed leaves. And then it says, what is the charge of the movable leaf? Well, again, the movable leaf is also negative. They went down. And in fact, I didn't say it, but maybe I should say the obvious. The reason then it moved out is because both of these are negative, and we know like charges repel each other. And so that's really what we saw. Still working on 18. What is the charge on the knob? Well, again, back to this picture. The knob is positive. Why does the leaf move? And I would just say like charges repel. Right? The movable leaf is negative. The fixed leaf is negative. They're right next to each other. They're each negative and one can move, so they push apart. Now, here's a fun one. What is the charge on the whole electroscope? And I would say the whole electroscope is still neutral. Right? This is like that neutral pit ball we did back in step 13. Right? It is polarized. If you were to add up all the positives and all the negatives in this electroscope, you would get a net charge of 0. But they are separated. We got positives up here, and I should say lack negatives up here. And then we've got those lacking negatives moving down to here, and so there's our negatives. So that's what is the idea of 18. Well, let's go on to 19. 19 says, touch the negatively charged strip to the knob of the electroscope and see what happens. Okay. So this time, instead of just bringing it close and then pulling it away, I'm going to actually touch it. All right, so remember this is negative, this is vinyl. So I'm going to rub it. It's going to transfer electrons from the wool onto the vinyl, okay. And now I'm going to bring it close, and not just close, but touch, and then pull away. And hopefully what you can see on the video is now the leaf stays out. It does not actually then collapse back down when I pull it away. So, touch the 19. Touch the negatively charged strip to the knob of the electroscope. What happens? All right, well, I guess at this point you can just say the leaf goes out, okay? But then it says remove the charge strip. Okay, so I did that. What happens? And then I would say the movable leaf stays out. Now watch this. Bring the negatively charged strip near the negatively charged electroscope and see what happens. All right, so let me try that. All right, so remember, I already touched it, and so you can see the movable leaf is already out. Does anything happen when I get closer? Do you see it sticks out a little bit more? Now when I pull it away, it collapses back down. But there is a little bit of interaction there. It does stick out a little bit more when I get close, and then collapses back down a little bit. But still remains out when I'm far from it. Okay, and then that's what they want you to see. And so what happens? And then it goes on to say, why do the leaves move further out? Well, let's talk about this. All right, let's come back to this picture. Now, let me change my drawing a little bit. Because what's different here is now I've actually touched the electroscope. And so I'm going to get rid of this word air and say, okay, now I bring the negative all the way near. And now, because they touch, like we did with the pit ball, and I guess that was step 4 way back then, some of the negatives can actually come off of the vinyl onto the knob. So I'll put a bunch there. But here's the other neat thing. Remember, the electroscope is a conductor. So when you have a bunch of negatives all packed on the knob, they don't like each other. They repel, so they move away. And so some of these, and I'll just kind of erase a few of the negatives from up here, will go down, and some of them will go on to the fixed leaf, and some of them will go on to the movable leaf. So it's not a surprise that we saw when I touched it, the leaf moved out. But what is more interesting then is when I take then the negatively charged strip away, those negatives are still on there. And that's why the leaf remains sticking out. And so that is the answer. Why do the... Oh, I'm sorry, I haven't gotten that far yet. Okay, so I've only showed you that the leaf would remain out. So then what would happen, and this is the question, when I bring the negative back near it, don't touch it, but just bring it back near it, these negatives that are in the knob are going to be chased down, maybe not all of them, so I'll leave one more up there, but more negatives go down, and that's going to make them repel even more, so it goes out a little bit. And when I take this strip away, a few of these, not all of them, will go back up to here. And so this negative strip, as I bring it close and far, is chasing electrons down, and then they go back up when I pull it away. But there still is an overall net negative on it because I originally touched it. And so again, that's what you'll see here. Where's my vinyl? I'll show you again here. So I bring it close and it moves out, and I bring down, it collapses back a little bit. So it always remains out a little bit because there's a net negative on here. I originally touched it. But I can make more negatives go down by just bringing it close to the knob. So did you notice the whole idea that these are conductors is really important? And did you notice also that the things that are moving are these negatives? I keep talking about those. All right, so back to this part of 19 I'm trying to answer. Why do the leaves move further apart? And I would just say because we're chasing negatives down to the leaves. Then it says check with your instructor because the atmosphere, blah, blah, blah. Okay, well, I'm your instructor, so it's working perfect. All right, so we don't need to check anything. And I think we've kind of answered number 20 here too. It says, with the negatively charged strip touching the electroscope, what is the charge on the leaf? So when I brought it close, when I actually touched it, and negatives transferred onto the knob and then conducted down to the leaves, those were negatives. And so that first part of 20 is, which ones were on the leaves? The negative. And then it says also in 20, what is the charge on the whole electroscope? And so in this case, unlike what we did earlier when we didn't touch the electroscope, this time when we touch the electroscope, I would say it is actually negative. The whole electroscope is negative. We actually transferred charge on there. Whereas the other one, remember, we just polarized the electroscope. This one we actually touched it, so the electroscope is actually negative. And then, of course, why do the leaves remain separated when the strip is removed? Well, I hope you caught that. When I pull this away, they remain separated because there still is negative. There's negative on the whole electroscope. The knob is negative. The fixed leaf is negative. The movable leaf is negative. They're negative. So, like charges repel each other. Yeah. And then the last part of 20, why do the leaves tend to partially collapse when the strip is removed? So again, when the strip is close, some of these negatives will be forced down to here. So when it removes, some negatives go up to here. Not all of them, so this still remains up. But that's why it partially collapses. It partially collapses when this strip is removed because some negatives leave the leaves and go up to the knob. So a lot of interesting stuff going on here. And so hopefully you're catching this whole idea, because it is this fundamental concept that really sets the base for fully understanding the electricity and magnetism stuff that's about to come throughout the rest of the semester. All right. Well, let's keep going here. Number 21. The electroscope is still charged negatively from the previous experiment. So let me just double check. Yeah, the leaf has still moved out. Charge now the acetate. All right, so let me come over here with the acetate. So charge the acetate with the wool and bring it near the electroscope. As you approach the electroscope, what happens? Explain what happens as you approach the electroscope. Something very different could happen. And this is going to be hard to see, so we'll hopefully see it. We'll see what happens here. But let me just begin by getting as much charge on here. And I don't hear it crackling, so I don't have much, but we'll see what happens. So if I bring it close, 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 close. Are you seeing the leaf go down? But watch this. What if I get even closer? Closer, 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 closer. Ooh, do you see the leaf go up? Let's watch that again. And fortunately, the answer is pretty easy. But it's kind of weird looking. Let's watch it again. So here's the acetate. Now remember, the acetate's positive, and remember the electroscope, we charge negative. Okay. So close, 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 leaf's going down, closer, leaf's going down, closer, leaf's going down, closer, 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 closer. Leaf's all the way down, closer still, and leaf goes up. Why? Well, I'll hold off on answering why because I think that's the next question here. And so let's see if we can just answer 21. 21, the first part of it says, as you approach the electroscope, what happens? So I would just say the leaf begins to collapse. Oh, then explain what is happening. Okay, so remember these are negative. Let me clean up my picture a little bit. So we've got negative, 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 negatives up here, and I have this time the acetates, positive getting close. Now, remember, positives attract the negatives. So what would be happening is this negative here would go up to there, and this negative here would go up to here. And the closer I get, the stronger this force is, and so more and more negatives keep getting pulled up. And so as they get pulled up, there is less negatives on the leaves down below. And that's why the leaves begin to collapse. That's the first half of this. And that's why it says explain what happens. And I would just say electrons are moving up from the leaves to the knob, and therefore the leaf is collapsing. But where it gets really interesting here, it says, as you approach the electroscope very closely, something different happens. And you saw that. The leaf begins to move out. It says, describe this. So that's describing it. The leaf begins to move out when I get real close. And explain this. And this is a key. Remember, when something is neutral, we don't mean no charge, we mean balanced. Because watch, if you get even closer, you will pull up, and hear this carefully, the last of the extra electrons. See, at this point, the leaf has completely collapsed because I have pulled up all the extra electrons. Are there still any electrons in here? Yes, there are lots of electrons because remember these are just now neutral. So there's an equal number of positives and negatives still in here. So if you get even closer, what will end up happening is you will start to draw up what I'm going to call the normal electrons. And if you draw up the normal electrons, you're lacking the electrons down on the leaves. And the leaves are now both positive, and now they begin to repel. So it almost looked like something weird was going on, that it was collapsing the leaves, and all of a sudden it started spreading out. And that's true, that's what happened. The leaves were starting to collapse because you were pulling up the extra electrons. And then when you got really, really close, the leaves started to spread out because you're pulling up more than the extra ones. You're pulling up what I'll call the normal ones. And it almost looked like something different was happening. And it really wasn't. It was just pulling up electrons. First it was pulling up the extra ones, and then it started pulling up the normal ones. And so when it started pulling up the normal ones, they started to become positive and they started repelling to each other. It's because remember, the leaves will repel each other if they're both positive or if they're both negative. So they started with both being negative and repelling each other and became less and less and less and less negative. And then they started becoming more and more positive, and so they began to repel each other again. So that one's a little trickier. All right, well, let's move on here. Let's try number 22. And really kind of finally coming to the end. And I hope I wasn't too long-winded here on this first one, but it's a really good lab here. So we've got 4 more questions to do, but they all kind of tie together here. Let me clean this up a little bit, because I think the first part of 22 says, start with a neutral electroscope. Let me read it here. Yeah, it says discharge the electroscope by touching it. So remember how we talked about way back with the pit ball that if you touch it, you ground it. So I'm going to go ahead and take my fingers, and I'm going to put my finger on it, and sure enough, ow, a little too hot. But like I said, I need the heat lamp here for today. But that neutralized it. Remember, all those electrons now came on me, and if, just for fun, I'll go ahead and neutralize myself here, and so I'll ground myself. Say, okay, so there they are. But I now have a neutral electroscope. So discharge the electroscope. So in my picture, I've got a neutral electroscope, and of course the leaves are collapsed. I won't change it in my picture, but the leaves are collapsed. It says charge the vinyl. And I just want to feel how warm that is, because this can get a little tricky because I got to touch it. Okay. It says discharge the electroscope by touching the knob. Now charge the vinyl. Is this the vinyl? Yeah, it's got a little blue to it. Yeah, okay. So charge the vinyl strip with the wool. Touch the knob with one finger while maintaining contact. Bring the charged vinyl strip near the knob. Now I'll divide this into a couple of steps here, but if you remember way back, I think it was 16, we just brought it near and pulled it away, right? And you can see the leaf move out. And in our picture, we were saying that's because when you bring the negatives near, the electrons go down. And so, okay. But watch this for a moment. What if I were to hold it? It's kind of warm. Oops, I don't want to block your view. What if I were to touch it?
Yeah, it's too hot.
Maybe I'll move it a little bit away. Maybe if I get the shadow side, it won't be, it's still pretty warm.
No,
Okay.
the white page is good at both behind the thing it's up there and I can see.
My apology. I got it a little too warm for me to physically touch. I wonder if I could touch it with something metal, like that I can touch it with. Oh, let me just see. This set of staplers would work. Ah. Not sure if this is gonna cut it. Maybe. Let's see if I can do this.
Yeah, it's too metal.
Okay, now ooh, that's hot. Okay, well, this was the bad side about what I just did. All right, maybe. Now I can't push that metal real well. Let's see what happens here. All right. Oh, thank you. All right, now I might have messed this one up too much. But if I touch it and bring it close, hopefully the leaf won't go out. If I don't touch it and bring it close, now I got too much moisture. Dang it. Okay, hang on. What if I bring another one into the picture that's I haven't messed up yet. Let's see. If I do this, and it's probably got still too much moisture in it. We'll try a different one.
That's on the bent leaf though.
Okay. And so, can I bring it close? Well, we might have tough luck with this one because I got to get them dry for today, and then I get it too hot to touch. Yeah, it was a little bit. But I'd like for you to see it more. Yeah, that one needs to dry out. So I ruined that one for a couple of hours. All right. So let's see. Just barely moves.
Maybe try this.
Yeah, maybe. But I already ruined that one by putting moisture on it. All right, so this one is starting to dry out enough that maybe I'm at a good position where it'll be dry, but not hot yet. So what if I touch it, bring it close, pull my finger, and pull it away. Good. All right, and you can see it losing its charge right away. So it's still quite a bit of moisture inside of there. That's what the water does here. But I'm not sure how well this is going to come out, so let me see if I can show you a second time. Hopefully you saw it there the first time, and I guess maybe that's the good thing about a video. You could see it a second time if you want. But did you see it actually moved out after I pulled the strip away? See, watch. If I don't have my finger here and I bring it close, the strip moves out and goes back. Nothing surprising about that. That's just chasing the negatives down. But my finger comes into play here. When I touch it, instead of the electrons going down to the leaf, they actually go on my finger. And so if I trap them on and pull away, and that barely moved out, I will get positives on there. And that's what they're trying to say. Let's read it here. It says, discharge the electroscope, charge the vinyl strip with the wool. Touch the knob with one finger, and while maintaining contact, bring the charged vinyl strip near the knob. Remove the finger from the knob first, then remove the strip. Bring the charged strip of vinyl back near the knob. What happens? What must be the sign of the charge on the leaves? All right, so let me try that. I'm going to neutralize it and neutralize myself. I'm going to bring it close, pull my finger, and then pull away. And the leaf goes out. And then, if I bring it close, notice the leaf goes down. That's a sign that the leaves are positive. Because remember, this negative strip chases the negatives down. And so if those leaves were already negative, they would move out as they did earlier. But this is a sign that by me touching it, somehow I've made those leaves positive. And so as I get it close, it pulls them away. And you can see it's losing charge pretty quickly. So again, this one's not as dry as it should be, but it's actually good. It's showing it, and it's not too hot, so I can actually touch it. And so that's this whole idea. And so to answer the question, number 22 says, what happens? Well, the leaves move down. Maybe I should backtrack a sentence. It says, bring the charged vinyl strip back near the knob. What happens? The leaves go down. And then this question, what must be the sign of the charge on the leaves? Well, they must be then positive. That's what I'm trying to convince you. And then, of course, the physics, and maybe I'll draw a picture here so you can kind of see the physics. It says here in 23, while the finger was touching the knob. Well, actually, let me hold off with the questions. Let me draw a picture and explain. So here's what's going on here. I'm bringing the negative near it. And as we already said earlier on, that if my finger wasn't touching it, it would chase negatives down and the leaves would repel. But when my finger is touching it, what happens is the negatives move instead of down. That's why when my finger was touching it and you brought it close, you didn't see the leaves move out. The negatives moved onto me. So I'll just put me over here. And so all these negatives are all over on me. And they're not down here on the leaf. Now, of course, what that means is the knob is becoming positive as the negatives get chased onto me. So the leaves don't do anything interesting. Then if I remove my finger, what that does is it blocks the path for the negatives to come off of me to get back on that electroscope. So when I remove my finger and remove this strip, this knob, which has now become positive, then draws up electrons from the leaves, neutralizing some of them up here. And so the knob becomes less positive. But in the process, the leaves become positive, and the leaves separate out. And of course, we saw that the proof that we knew the leaves were positive, because when I brought the negative near it, which the negatives would take some of the negatives that are up here and force them down, neutralizing them, we saw the leaves collapse. So that was our evidence that the leaves must have been positive after we did this little weird mechanism of touching it. And by the way, this is called charge by induction, charge by induction. And so I induced a positive charge. I always find it interesting that I used a negative object and I charged the electroscope positive. Because literally what I did is I used the negative object to chase negatives off the electroscope and onto me, thereby leaving the electroscope positive. And so, like I said, I always find this one the hardest one to understand, the hardest one to explain, and very interesting that I used a negative object to charge something positive. So I'll say it again, you use the negative to chase them off onto something else. That's why it's called an induced charge. And so you're left with a positive on there. So now I think we can answer the step 23. It says here, while the finger was touching the knob and the negatively charged vinyl was nearby, what charges went onto your finger? And so hopefully in that picture you said that what went onto my finger were the negatives. And I would say they went well beyond my finger. The negatives went all throughout my body. What is the charge on the electroscope when the finger is removed? See, there's the key, positive, because remember you chase the negatives onto you. Therefore, the electroscope is lacking the negatives. When the finger and the vinyl strip are removed, why were the leaves separated? Well, the leaves separated because they are each positive, and positives repel. When the negatively charged strip was brought near the electroscope, why did the leaves collapse? Well, again, I think I explained that they collapsed because I was chasing negatives down to the leaves that were positive. I was neutralizing them, and then they had less of a repulsion, and so they collapsed back down. So that charge by induction is a tricky one, but hopefully you see that here. Well, that brings us really kind of to the basic end here. 24 and 25 go together. They're kind of a little history lesson here. But it says here, given what you know, and so what they mean by that is given that you know vinyl is negative and acetate is positive, could you describe a process, a procedure, that we could then find the charge of other unknown objects? So in this case, they're going to ask us in number 25 to actually find out what happens with glass and what happens with rubber. And there's more than one way to answer this. I'll just kind of do the wrong one first. The wrong one is to say, start with a neutral electroscope. Because if you remember, if you bring a negative near the neutral electroscope, it chases negatives down and they repel. But if you bring a positive near a neutral electroscope, you suck negatives up, making the leads positives, and they still repel out. So you can't tell the difference in response on this electroscope between bringing a negative near it and bringing a positive near it. They both make the leaves go out. Now, I would say maybe it's a different reason, because this one chases electrons down and this one sucks electrons up. Okay. But the whole point of step 24 is to point out that if you wanted to figure out a procedure to get the charge, a neutral electroscope is not going to do it. That's why you have to know the sign of the electroscope. So let's do this. Let's say, what if I do this? What if I were to charge the electroscope by actually touching it with this and making it negative? And so when I make it negative, then the leaves are negative. And that means if I bring a negative near it, the leaves will spread out even more. But if I bring a positive near it, that will suck the electrons up and the leaves will collapse. And so I'll get a different response. So that's one of many ways you can answer this, but no matter how you answer number 24, you must start with a charged electroscope. Whether it's charged negative or charged positive doesn't really matter, but you must have a charged electroscope. You can't have a neutral one. So I will charge it negative. And so that's my description. And I'll even show you. So if I go ahead and I actually bring it close and touch it, the leaf stays out.